colloquium that we scheduled to give some topical issues to small-scale growers in the region, and everyone is also welcome to join us. So we'll get started here by asking, so today the topic is, just let me give a little bit of what is going on, if people are not familiar with Zoom. So you can use this button here on your Zoom. It can be up or down. You can use it to mute yourself or unmute if you want to give a talk. And you can also close your video button from here. And here you can chat. If you want to ask a question, you can use a chat box to ask the question. And then we'll be able to respond to you appropriately. Yeah, so commercial horticulture is a new program that has been developed by the University of Arizona to take care of commercial horticulture and small acreage growers in Evapotranspiration and Colloquium County. And our programs, we open it to everyone who is out of the county and willing to participate and learn something from our programs. So though it's for Evapotranspiration and Colloquium, all others are welcome to join us to share knowledge. So basically, a little brief, we are looking at, based on the need assessment, we grouped our programs into soil health and fertility, integrated pest management, specialty crops, and seasonal extension. We also have field crops, and then winter irrigation and water, which is what we are going to talk about today. So I'll invite Mike, who is a professor and specialist for University of Arizona, to give us a talk on what the drought situation is like in Arizona now. And then after his talk, James, who works with NRCS, will also give us some practical applications, how we can manage water well in our fields to maximize water use. So Mike, if you're ready, I'll stop sharing right here so you take over from here.
Okay, thanks, Isaac. Okay, so I'm going to try to go into presentation mode. I always see if this works. Can you see the presentation?
Yes, it looks good.
Okay, good. Okay, so hopefully it says Arizona Climate Update and Drought Outlook. Isaac, thanks so much for the invitation. I'm really excited that you put these webinars together. I'm Mike Crimmins. As Isaac said, I'm a professor in the Department of Environmental Science down in Tucson, and I'm the state climate extension specialist for, well, the extension specialist, statewide extension specialist for climate science. And so I'm going to give you a little bit of a peek into these topics today, the conditions over the past 12 months. We'll talk about what this monsoon season looks like, and then we'll look at some of the outlooks for the upcoming fall and winter season. And I never am able to give a talk with good news in it anymore, it seems like. So we have had quite a year, and it's been yet another strange year. And I could say that probably about the last 5 years or maybe even 10 years here in Arizona. A year ago, this is the Drought Monitor Map, and it's going to go in sequential order from June 25th, 2019 in the upper left corner to the right, down to the lower left and across to the right. But I just want to show you the progression. On June 25th of 2019, we were actually, if you can remember back to spring of 2019, we had a really pretty good winter. And you could see that drought was erased from much of the west. There's a little sliver of drought in western New Mexico and really far northern Pacific Northwest, but a pretty rare drought monitor map coming into the monsoon season. The outlook at that time for the monsoon season was a little bit, there was certainly a lean towards dry, some indications that some kind of lingering El Nino conditions were going to mess with our monsoon season, and they certainly did. So by the end of the monsoon season, October 1st, you could see that the drought of the entire western US was really relegated to the Four Corners and then down through much of Arizona. And you can see much of Coconino County and parts of Yavapai County even got down into severe drought by the end of the monsoon season. Then we turn it around again. It starts raining in November. November was actually a very wet month. And then we kind of intervening months did quite well with precip all the way through the springtime season. The far northern part of Arizona, far northern Coconino and across much of the Four Corners region there, didn't quite get as much activity as basically kind of Flagstaff south through the rest of the state. So the drought conditions eased there from the summer drought of the monsoon season last year. And we held on to those severe drought conditions. And then here we are. This is the drought monitor map from last week, and it's being edited right now. And we're actually seeing some pretty big drops in drought degradation. So we're going to see severe drought and even some extreme drought creep into Arizona with the update that's underway this week. So it's a pretty harsh turn of events going from just about a year ago up until present. So we can look at a couple of maps here and try to figure out why the drought monitor map did what it did. So we can look at a metric of drought here. The upper plot is a standardized precipitation index, and that's going to take 12 months of total precipitations. It's going to be last August through the end of last month through July. We're going to look at all other 12-month periods of that same time period and look in the historical record over 120 years worth of data. Now we can rank them and get a feel for their standard deviation. So if it's white, that means it's near the average for the long-term average for that 12-month period. If it's green, the blues, it's going to be above average, and if it's red, it's below average. So you can see, as I was saying before, that in that 12-month period, the precip from November all the way through, we even got a little bit in May, kind of held things at bay and improved drought conditions from basically kind of Flagstaff south, and even the southwest part of the state, which is normally doesn't get a lot of rain, but got quite a bit. And far southeast Arizona did well. Overall, most of the state in that 12-month period did see near average precipitation. Four Corners region, and where we saw the drought really hang on and continue to get worse this summer, is where those below average conditions are. The lower plot, though, is going to take into account the temperature. This was a really warm spring, and it's become a very hot summer. So got this trend on top of things, and it not raining has really enhanced and exacerbated the drought conditions. So even areas that saw near average precipitation in the last 12 months, the added effect of temperature on top of that is increasing evapotranspiration. So it's washing out any of the potential gains we've had over the last 12 months. So here we can rank order things. We look at that same time period, August through July, and you can see that most of the state near average was much below average. Just in the far northeast corner of the state, far southern part of the state was near normal to above normal. And then on the temperature side, you can see almost all of the state was in the top 10th or top 10 percentile of temperatures in the last 12 months. And once we just look at, and if we look at just the summertime, we're in really record territory as far as temperatures. Okay, so last monsoon season, I probably don't need to remind you on how poor it was. It was really kind of a break from north to south. It's interesting too, we really whined about how bad the monsoon was last year. We didn't know how bad it could get, and we're learning this particular monsoon season, which I'll talk about. Southeast part of the state did not great, but not as bad as it's doing this year. But the far northern part of the state ended up having its driest June, July, August on record, and that was last summer. And you can see here the near average to maybe slightly above average reached up towards Prescott. Flagstaff had its driest summer on record, so it was a really miserable monsoon by all accounts. And the progression of the activity, these are some plots I have on one of my websites. We can look at the height of the green bars is the percent of Arizona observing any rainfall at all. So you can get to see how the extent of these rainfall events. So the biggest, most active period was late July and into early August, where we got up to one day where almost 80% of the state saw precipitation, then a big break through much of August. And it wasn't until we got into the end of September, which is when we ended up having something that was really more kind of early winter type activity intersecting with some tropical storm activity, that we ended up having our biggest event of the entire monsoon season, and it really wasn't even a monsoon type situation. Okay, so we can look at some plots here. This is what the progression of precip looked like from June 15th through September 30th of 2019, so monsoon season proper. And that's how you get to be the driest summer on record. So in a 70-year record, that total of just a little over 2 inches, 2.08 inches, was the driest on record. And it's just a really miserable looking plot with a lot of brown there showing the below average conditions. So only seeing 2 inches in about 20 days when they would normally see about 32 days of precipitation, and a little bit later as far as the shift of precip as well. Prescott did a little bit better, but not a whole lot better. It wasn't the driest on record, but it was certainly in the bottom 10 of driest summers on record. And this is about 4.5 inches for Prescott last summer, and it occurred on about 20 days when you'd see about just close to 30 days of precip. So there were smaller events, kind of light to moderate were the most frequent events through the whole summer last year. All right, so that was kind of a bummer last summer. We didn't know what was going to happen for the winter season once we got out of the monsoon season. October was very, very dry. Ended up having one very cold freezing event, right? Actually two, one in the middle part of the month and then one right around the end of the month towards Halloween. And set us up, well, we didn't know how to set up, but we were moving into a very, very wet November period. And we did not have an El Nino or La Nina on deck last summer, so it was really just a natural variability. We picked up a pretty active weather pattern that kept kind of rolling out some good storms and even some decent snowpack throughout the winter time. Not great snowpack, but decent, especially down in Arizona. It ended up melting off pretty quick in the spring though as temperatures warmed up. But overall, from the November through June period, we were in the kind of above to much above normal for much of the state. Definitely not record wettest, but the whole Southwest did pretty well. You can see that Colorado, though, really got left out of that action, and that's playing into some of our reservoir level issues that are emerging this kind of now. Lake Mead is at 40% capacity. We can look at these plots again. This is for the cool season, what I call cool season. So it'll be October 1st, and this goes through May 31st. Flagstaff ended up having a little over 15 inches, about 70 inches of snow total, and on 42 precipitation days of the season. So a little bit above average, about average on the number of days they would see, and a couple of heavy events there in November. So overall, what I was really pleased with was we didn't get all the precipitation in 1 month and it just never rained again. We kind of had an event a month, one event each month all the way through May even. We even had a couple of small events in May, even as it did warm up quite a bit. But it's not a bad way to do a fall, winter, spring here in Arizona if we could do that every year. Prescott kind of did the same. Had a big event in late October, picked up quite a bit of precip. So right out of the gate was up over 2 inches. Slowed down a little bit December, January, but then February picked up again. Actually, I'm sorry, I'm not showing the right plot. This is from, did I get the right one? Yeah, 2018, 2019. I might be actually a year off. I apologize. I think I put up the previous year's plot. Did I do that right? Nope, I did. I'm sorry. I will send that out. This is the wrong plot. The plot from the right time period last year looks pretty good as well. So we'll skip that one. Okay, so basically what this puts us at is, here's a plot of looking at all these drought timescales. We can think of drought on short timescales and long timescales. And what I really just want to focus you on this plot is looking for those green stripes. Those green stripes are where we're out of drought, and the brown are where we're in drought. And so as we kind of go along the x-axis, that's time, but up the y-axis is the length of those droughts. And so the 2002 drought was a very intense long-term drought, and it led to long-term drought conditions well 5 years past when the drought really started, was even kind of prior to 2002. So you can see in the last basically 5 years, we've had enough precipitation and even picking up the winter and the odd good summer that we're kind of digging ourselves out of the long-term drought situation. But we've had a couple turnarounds here. That the 2017-2018 was a really bad winter. The summer was okay in the intermediate, and now we've had a couple of good winters, but now we're back into a bad summer. So we can't quite pull it off where we get a run a good even winter, summer, summer, winter seasons together. So even with last good winter, we're now canceling it out by our summer situation right now, which I'll talk about the monsoon right now. Okay, so monsoon season 2020. Here's a couple of different plots here focused on Arizona. So this is going to be total precipitation for June 15th through August 15th. So it's just about 2 days ago. And the upper left plot is the total, and then the percent of average is the lower right here. And so as Jeff and Isaac and I were talking about kind of early before the call here, there's a little bullseye just north of Prescott, and we'll take a look at some of those observations. So we've had very spotty, intense precip in some locations, but overall, most of the Southwest, most of Arizona is not having a banner year at all. Far southeast Arizona has had some decent activity, mostly below average. A couple pockets in and around Flagstaff have picked up some heavy rain, but largely they've been a few very heavy events, not good sustained rain every couple of days from June 15th to present. It's been very fits and starts. Most locations in the low deserts haven't even seen precipitation yet this year. So these plots will kind of highlight that a bit. The upper left is the max 1 day precip. So you can see there that this radar estimated, gauge estimated map here is picking up anywhere from 2.5 to 3.5 inch totals in between Prescott and Flagstaff. So that ends up being one of the biggest bullseyes of the entire state. We had a big heavy event just outside of Tucson. There's a couple in and around Tucson that's across southeast Arizona, but as far as 1 day totals of the whole monsoon season, you're kind of right in your backyard there with some pretty heavy rain. The lower right is the daily intensity index, so it's just dividing the number of the total precip by the number of days of rain, just to give it an idea. And so you can see those little purple and red areas are locations where most of the seasonal total has occurred in 1 or 2 events. Okay, so this year, I believe this is the right plot. This is 2020 monsoon at Flagstaff. Not great. It's definitely falling behind. This real break in activity from mid to late July up to present is leading to really quickly growing deficits here from the official observation at the airport in Flagstaff. So we could end up with the driest on record if it doesn't rain again, but yeah, we're about ½ inch off of the total from last year, which was subsequent driest on record. We have about 6 weeks left in monsoon activity. That's generous. It's probably more like 4. So is this possible? It is unfortunately possible that we break the record again this year, but there's still a bit of time and still a bit of activity possible on our forecast up the next couple of weeks. But again, it doesn't look great. Prescott, not good either. So if it doesn't rain again in Prescott officially at the official co-op station, then that would be the driest year on record. But knowing that there were a couple of locations in and around Prescott that have actually picked up quite a bit of precip is good news. Okay, so I pulled up the rain log observations. So this would be the same period. This would be June 15th through the 16th of August. And it's really quite interesting. You can see some really dry observations around Sedona. Some decent ones, better than the airport around Flagstaff, and then some really pretty impressive readings down in and around Prescott. See a 3.85 there and a couple of 3 inches just outside of town, and then a lot of 1.5 inches. So it's just how the monsoon season goes out here. But the storms have been especially isolated. We haven't really had a widespread large event yet this monsoon season, which is a bit unusual to get up to the middle of August and not have a big rainer cover some more geography than it has already. Okay, so why? So what we've struggled with this monsoon season is what we rely on with the monsoon circulation is our upper level ridge, our mid-level ridge at about 20,000 feet in the atmosphere, the Four Corners high, if you hear about tucked on the news, has not been near the Four Corners much at all this entire monsoon season. It's been hanging out overhead or over northern Mexico and then kind of wandering around. And the broad pattern across the entire northern hemisphere has been this real deep trough over Alaska, and it's translated into a weak trough off the California coast. And that's really from the north shoved the monsoon ridge out of position and messed with it all season long. It just keeps getting bullied and shoved around, and it can never set up for very long to let any moisture into the region, which is what we've suffered with. And so this just highlights that H should be up over the Four Corners and has been more overhead or over northern Mexico, which is what it looks like in May and what it looks like again in October. So we've never kind of gotten out of the springtime pattern this season. And you can see here that it's actually caused problems well down into Mexico. So those brown areas, you can see Arizona falling behind, but the North American monsoon system really is most robust in Mexico, and it's not even very active in northern Mexico, which is where you'd expect it. And if it's not active in northern Mexico, it's not going to be active in Arizona, because we rely on that moisture to slosh into from the south and into the southwest. Okay, so what does it look like? This is where I always wish that I could turn it around and give you a little bit of good news, but the outlooks just have been, I never usually put a lot of credence in them because they're hard to do at 8 to 14 days, make a good forecast, but they've been really pretty solid all monsoon season, and they've leaned dry and they've been right. And so this was an outlook made yesterday. I haven't looked at today's outlook, but it has a pretty strong bullseye across much of Arizona. Maybe take a little bit of hope that far northern Arizona is in a kind of weaker shade of brown, which would mean less confidence in that. And the experimental week 3-4 outlook, which would put us to the end of August, and that's through September 11th, which is, we don't get a whole lot of activity after that period. So it's a lean dry. It's not a strong forecast though. It doesn't have real strong contours on it of confidence. And the forecast discussion basically is saying that the East Pacific tropical storm season has been very quiet right up until about this week. And it looks like it's going to open up and it's going to be quite busy. And it could be quite busy for a couple of weeks. And so that really is our best hope at getting something that would look like a real monsoon, widespread monsoon event, which would be a Gulf surge of moisture up the Gulf of California, fill up Arizona with some good moisture, and then we can capitalize on it, which we haven't seen yet this monsoon season. So there's a little bit of hint of hope in the discussion around this forecast, but overall, the monsoon has just not set up and we're running out of time. So the fall climate outlooks, and so this is where we're going to kind of shift out of monsoon season, and by September 15th, it's pretty much, we're back to fall weather pattern, and then there's always the possibility of something tropical from the 15th to 30th, and well into October too. We can get really good, big, widespread events, but they are unpredictable, and you can't rely on them for anything meaningful. And especially for ranching, it's just way too late. The growing season is over. So I think that that's where we got some real problems to deal with on the ground right now. It's going to be warm. There's this ridge of high pressure still is giving us the heat, even if it's giving us the rain. And there's that bullseye of below average conditions across the kind of the central Rockies there. And it doesn't really extend down into Arizona. And that's mostly because we're in kind of a dry season transition at that point. So there isn't real good confidence that's going to affect us. And if things couldn't get worse, we actually have a La Nina event developing, and there's some growing confidence that it looks like this thing is actually going to happen. And so La Nina events, they typically form about this time of year, and they mature late fall, and they peak kind of midwinter, and then we're usually out of them in the spring. La Nina events are pretty reliable indicators of below average precipitation for Arizona, and especially for southern Arizona. So this is one of those situations where we have a dry summer and a dry winter possibility, and we don't often see that. We usually have some interplay and some trading on and off, but this could be that rare situation where we stack a pretty miserable monsoon on a drier than average winter. It's not a done deal. We still have some monsoon season left, but I think it's just good for situational awareness to know that this La Nina does look like it might happen. If we look at historical La Nina events, El Nino to La Nina events, so El Nino events would be the red dots on the right. This is total October, November, December, January, February, March precipitation, so kind of cool season precip. This is for Yavapai County. We look historically from 1950 through 2018. I need to update this through 2020, but if we just look at that period right now, you can see you could kind of fit a line through the red dots to the green to the blue, and it slopes. And what that tells us is that you can see that most of your dry years are La Nina events. And we're looking at an event that's probably a -0.5 to -1. So you can see what kind of years have in the past. There's a handful of there's about 4 that were above average, but there's a good cluster that were quite dry, and that's the concern. In 2018, our last kind of deep drought year was a La Nina of similar character and intensity. So we just have to keep an eye on that. Again, it's not a done deal, but this is as good as we can do with seasonal outlooks. So the precipitation forecast, so this is going to be September, October, November in the upper left, goes all the way in these 3-month moving periods down through February, March, April. And you can see that brown shading of increased chances of below average 3-month precip is hanging around Arizona. And it's got these little bullseyes that hang around, especially southern Arizona, but include most of the state. And that's that expectation of La Nina occurring. And then temperature outlooks, they're hot. Well, they're not hot. Well, they're hot if it's today, that's for sure. But they're above average, right? And so this is really leaning on, this is that kind of climate change trend come home, and we just have trend. We have lots of trends, so it's a safe bet, especially in the Southwest, that every subsequent season is going to have a better chance of being above average than below. So you end up seeing this kind of there. So got to get through this monsoon season. Hope we can pick up a little bit of precip. But we're really fighting with all of this extra heat because we're not getting the rain, and we've got this trend on top of it, and then now we're staring down a La Nina. So I'm ready for 2020 to be done. That's kind of my ending statement here. So I may have a minute or two for questions. I'll let Isaac kind of deal with that, but I'm always happy to field any questions. You can give me a call or drop me an email, and yeah, thank you so much.
Great. Thank you very much. I think we'll reserve the questions. If there's any, we just got some good news that it's raining in Chino Valley.
Okay, good. Is Jeff lying to you?
Yeah. So we'll ask James to give his talk now. James is going to give us his talk about how we can manage water situations in our field, looking at the drought spells that we are having, how we can manage water situations to maximize water use. So James, if you can hear me, you can take over now.
Yes, yeah, I can hear you. Okay. And I'm having some occasional issues with my internet is being unstable, so we'll hope for the best that that things don't get unstable, and guess we're ready to
okay, we'll keep our fingers crossed, hoping that your internet will not.
I wanted to do a share screen, I believe. Can you see my screen at all?
No.
Yeah, I'm not doing something right.
You just, if you click on the share screen, let me see. It's right at the bottom or probably at the top of your.
Do we get it there?
Yeah.
Okay.
So now you can put it in presentation mode.
From the beginning, please.
Okay. Looks good.
Okay.
Yeah.
My name is Jim Harrigan, and I'm the MLRA leader. MLRA stands for Major Land Resource Area. For the Colorado Plateaus, basically the Colorado Plateau is my area. Extends from around the Flagstaff area out into New Mexico and into Utah and a little bit of Colorado. The material comes from NRCS. All of this material came from online. So it's available in places, but this is a presentation I made up from that. I'm going to start with a little bit of introduction to soils and go into soil health and water conservation from there. So to give a little bit of background about soils, what is soil? It's naturally occurring unconsolidated matter at the Earth's surface, which is capable of supporting plant life. So this is a Sinol lava flow. It's got a lot of bunch grass growing and a beautiful rainbow, which would be nice to have seen today, but we didn't. But these are the components of soils. The soil is made from minerals, water, air, and organic matter. And the pie chart on the right is a good farm soil. You can see the bulk of it is made from soil and minerals. There are pockets of air and water. Of course, there's more water when there's more precipitation, and about 5% organic matter. And the rest of it is less than 1%, of the rest of being salts. And a rain soil is more like the one that's in the bottom of the pie chart. Rock takes up a good percentage, so you have less air, less water, less organic matter. Rocky soils are good for grazing, but it's about what we can do with a lot of plateau soils. Out in the Verde Valley, you get some good farm soils. From Chinle Valley and around Loop, there's some good farm soils. Mainly our farm soils are limited to those valleys. I'll talk about physical soil properties now. There's some soil properties that we can't change and we have to live with, and other soil properties that we manage appropriately to our best advantage. We can do a lot with. Some of the things we can't change much is depth and texture. We can alter the structure and we can improve structures of soils, and structure does make a big difference in water conservation. We'll talk about that. Drainage, runoff, and evaporation. Evapotranspiration are things that are affected by basically the other three things. I'll talk about soil depth first. Our very deep farm soil, we can imagine water, whether it's flood irrigation or rainfall, moving down the profile. And out in the Midwest, where they have plenty of rainfall, they talk about infiltration and water moving down the profile. And it's pretty constant there. But out in the West, sometimes water can move up the profile if we don't have enough rainfall. And that's especially true if you have a loamy or a clay soil. Clays have a way of drawing water to them because they have absorptive qualities. Over on the other side here, we have a rain soil, and you can picture if rain were falling on this, it would change quite. It would have a major impact that is shallow to bedrock. You have a lot more runoff Um, we use this quite a bit in these types of soils, and cattle ranches and sheep is a big deal in Coconino County. We have a lot of acres in sheep. Okay, soil texture. Have this picture here on the left, relative comparison of different grains, the sand being the large grains, silt being a small grain, less than 0.05 millimeters. These don't have absorptive qualities, but the clay particle, the smallest particle, those usually do have absorptive qualities, and we'll talk about that a little bit more. If you've ever seen a school bus get stuck in the mud or get stuck somewhere, you can tell whether you're in silt or clay by what happens. And if the wheels are just spinning and nothing else seems to be happening, you're probably in silt, because the silt doesn't stick to the tire. But if the wheels are turning and mud is being thrown everywhere, you're in clay. And then there's sand. Gravel would be too big to show here, but gravel makes for some good roads. I've just put this textural classes up here to show kind of what we talk about when we talk about what types of textures there are. Clay textures are the absorptive clays, the smallest grains. Sand are the large particles, and silt. And loam is usually the desirable soils, although silt can also be pretty good soils too. Too much clay, it tends to get real hard, although it holds the water real well. And sand doesn't hold water. Some things about sand and textures that are important. All texture determines how water moves through the soil. And that's very important out our way, because since we don't have extra water, the soil forms the matrix and determines how water has to move through the soil. And whatever you grow has to be adapted for the way the water moves through the soil. Say sand, for example. Sand would require something that's can find water deep down in the profile. We did a tally of our ecological sites in the desert and the woodland steppes that are prevalent, and the Colorado Plateau. We have more ecological sites than any other major land resource area in the nation. Deserts tend to produce a wide variety of plants because a plant has to be able to have an adaptation for finding water and minerals in the soil. And so So plants have to be a little bit crafty to be able to pick up the water and the minerals in the soil. It determines how water moves through the soil. You can get excessive drainage. We don't have too many problems with poor drainage simply because you just don't have that much water. You can get poor drainage in a depression. A lot of people would like to have more areas of poor drainage simply because they make good tanks for cattle. Determines how much water stays in the soil, which is related to evapotranspiration, and I'll get into that in a little bit, and how nutrients move and enter in the soil, and how roots penetrate the soil. Excuse me, big word. Evapotranspiration. That's the sum of water that evaporates from the ground and also transpires through plants. How do you reduce this? If you can reduce evapotranspiration, you can conserve water in the soil. So if water falls on the earth and it's exposed to clay, you have some clay on the surface, it'll adhere to the clay, and then once the source of the water stops, the sun will dry it out. So the soil water is lost to evaporation. What happens is the water that was down below the surface will be drawn up, and that water will be dried up by the sun. So this is key to reducing evapotranspiration, is to cover the soil. Organic mulch is nice. It's expensive to buy and distribute. Some alternatives are leaving organic leaf litter, keep that top cool, the top of the surface cool, and so it doesn't evaporate so fast. Or plant cover crops, and these are ways to cool the surface and to break some of that water that's constantly being drawn up from down below in your soil profile. Keeps it from being drawn up continually from below. Here's our picture of a water cycle, and probably all seen this somewhere in either in school or maybe in a poster on a wall. The two things you can control here are the surface runoff and the evapotranspiration. Soil drainage. Poor soil drainage can add to flooding problems. If you have clay on the surface and depression, it'll cause drowning of the plant, basically. Your oxygen will eventually be lost from the soil. With our sand, you can kind of visualize what happens if it rains on our sand and we lose it deep in the profile. So sand doesn't have any, it doesn't adhere, so it can be lost to the wind. So especially a fine sand or a very fine sand or silt. Don't have very much of that in Arizona. A lot of our our silt will end up in southwest Colorado, out there near Cortez. If you happen to be up there, you'll see very deep piles of silt, and I started my career out that way. They don't get that much rainfall, but the silt is real good for pinto beans and alfalfa. They can grow it without extra water. Soil structure is a part of the physical structure of soils that we can manage. Can't do anything about the texture or the sometimes the amount of water we can get, but we can do something with the structure. Structure is how soil breaks naturally. If you pick up, you can start with a clod, but what I'm talking about is different than a clod. It's a bed, the way it naturally breaks, not how you rip it. That would be if you rip it with tillage, that would be called a clod. Some different types of structure. This is basically what we want, either granular or blocky structure, something with some pores in it so that the water can go through the soil, penetrate the soil and filtrate naturally, and not too fast, not too slow. This is kind of a couple down here, is a couple that we don't like so much. The massive soil structure is when we lose our PEDs. Now, columnar and prismatic, usually those are related to a little bit of salinity. Don't see that much around here. You might see it in the Chinle Valley and up north where you have like some shale salt source. But you can get that in the desert with continual evaporation, accumulation of salts. And single grain textures is just sand. We'll talk about soil health now. Soil health is assessment of the ability of the soil to meet its range of ecosystem functions appropriate to its environment. That's kind of wordy and academic. How well a soil provides a habitat for symbiotic living organisms. Living organisms are essential to good structure. Soil creatures are critical to the soil health. They help build soil structure, and they limit erosion and aid water availability, protect crops from pests and diseases, decompose organic material and cycle nutrients. Going to go quickly through the next couple of slides because a little bit behind, but these are examples of our creatures that live in the soils. There's nematodes and arthropods. They all have a role. The fungi is a especially good one that helps provide minerals at the surface of roots. Some pictures of these. We can go through each one of these. But a key one also is the arthropods. They help shred organic material and break things down. They enhance soil aggregation. By that I mean they improve soil structure drastically with the little casts that they leave behind. The little casts, they act as a glue that holds the structure of the soil together in a really very desirable way. Organisms consume other organisms, excrete inorganic waste. Mineralization and immobilization is a couple of ways that nutrients are provided. This is pretty much the meat of the healthy soils, though. The ways to manage soils and reduce the amount of water being lost in the soils. Keep it covered. Do not disturb the soils. Use cover crops such as ryegrass, buckwheat, clover if you have plenty of water. These things will help protect your soil between crops. Rotation. Rotate your crops to feed your soil. Develop a soil health management plan. Pictures are a seed drill. Now, seed drills won't disturb the structure of your soil, which is much better than what a plow would do. Plow destroys the structure of your water, or excuse me, your soil, and you'll lose a lot more water if you plow your soil up. It'll be exposure clays, and clays will be drawing water from out of your profile. So don't disturb your soil. Limit tillage. Optimize chemical inputs. If you put chemicals into your soil, you don't want to run over your soil. So you would preferably want to do that just once. Rotate livestock. Don't leave them on too long because they will eventually cause trampling. So no-till when practical, use a seed drill. Drive through the field as little as possible. Rotate livestock and limit trampling. Keep it covered. Keep your soil covered. You plant cover crops. Use organic mulch when it's available. As it becomes available, cover crops protect soil from the wind and water erosion while improving soil water, and mulch helps hold the soil in place. Maximize biodiversity. Rotate crops, integrate livestock. Maximize biodiversity. That can improve soil health and nutrient availability and break disease cycles. I'll always encourage new roots. Fallow is not something that's very desirable. You want to plant cover crops when they're available. Living roots reduced soil erosion and provide food for organisms that cycle nutrients. What are benefits of a healthy soil? They hold more water. You lose less water to runoff and evaporation. Organic matter builds as tillage declines. Plants and residue cover the soil. Organic matter holds 18 to 20 times its weight in water and recycles nutrients for plants to use. 1% of organic matter in the top 6 inches will hold approximately 27,000 gallons of water per acre. Most farmers can increase their soil organic matter in 3 to 10 years if they're motivated about adopting conservation practices to achieve this goal. 4 basic soil health principles to improve soil health and sustainability. Use plant diversity to increase diversity in the soil. Manage soils by disturbing them less. Keep plants growing throughout the year to feed the soil. That means cover crops. Keep the soil covered as much as possible. Quickly, I'll go through some things NRCS has available online. One is soil survey. Web soil survey gives you a map of soils. From that, you can get interpretations such as how to manage recreation developments, construction, material considerations, so forth. There are these plant guides. Plant guides might help you to select a cover crop that's right for you, right for your farm. NRCS Planted Database gives you some information about how to identify plants, where they grow. Some things on YouTube. And these things are really good. You can do these anytime. This one that's really good is the Soil Health Principles by Archuleta. He'll show you how tilling destroys the structure of your soil, and by not tilling or reducing tillage, you can get a much better soil for conserving and holding water. NRCS Soil Health is another good one. That one talks more about the things that I've just covered. 90 seconds to discover new hope in the soil is a better conclusion to why soil conservation and water conservation is important. And that's all I have for you today. I can take some questions.
Thank you, Jim. Thank you very much for the detailed presentation you gave us. So now we are a little bit behind time, so we'll open the floor for some questions if there are some concerns, so we can try to discuss them. So you can unmute yourself and ask your question, or just type it in the chat box. Whilst we are doing this, I will share a diagram with us that kind of summarizes all that has been said. So with this diagram, to maximize the water use on our field, looking at the drought situations, we have to intensify irrigation practices and practices such as irrigation technologies and best management practices. And we cannot do one of it in isolation, cannot do, but when we combine these practices, we can reduce how much water we put in our fields and to maximize the efficiencies. And the best management practices are basically what James was talking about, the soil health practices and all these conservative practices. Yeah, so if there is any other questions and concerns, we can have some more discussions on that. No question? Not to Mike too? Jeff, you have a question?
It was a comment, and I just wanted to know if others on the call are experimenting with cover crops and thinking about planting them in the fall.
Jeff, can you hear me?
I can.
Yes.
Hello?
Yeah, we can hear you.
Okay, I have a question. We're always told, you know, don't till the soil, you know, plant cover crops, but at some point, don't you have to till those cover crops in?
I'm not sure if the line was a little bit breaking. Can you repeat that?
Oh, Julia. Oh, go ahead.
Isaac, I'll paraphrase.
What I was
She just said, don't you have to till if you use cover crops to get them in contact with the soil? That's what she's.
It's good to leave what you have on the ground if you can, because that'll keep things covered. You might like to mow it, maybe, but yeah, I would hold back on tilling the soil. There may be some calls for tilling. One is compaction. There's not really another way to get around compaction if you've driven over your soil too much. The only way is to break it up again. But that's the only one I know of offhand.
Yeah, so with what James is saying, what we can also do is that to break the compaction in the field, we can also use some cover crops that are like radiation and stuff that has tubers that can grow deep in to kind of break those compactions, apart from trying to avoid it if we happen to have it. Those are the kind of cover crops that we can use to break the compactions. Yeah. Okay. Any more questions?
You know, I would just add, Isaac, on a farm scale, no-till works pretty well, and on a backyard scale, I think what people call it is lasagna gardening, where they just keep adding and then planting into that. And I think we have some both backyard gardeners and some farmers on this call today. But you know, one of the biggest holdups for us that I've run into in Yavapai County is the availability of a seed drill, and finding where those are and helping people find out how they can get access to one or buy an old one or something like that is probably going to be one of the first steps for us to adopt some greater no-till practices on the small farm level. So that's just a comment, but James is absolutely right. But I think most backyard gardeners would prefer, you know, they just want to get that organic matter in the ground, and they can mulch with something else, and you know, they can use cardboard and things like that. But the farmers need to look at something that's, you know, a greater scale. So that's the divide. And your audience here is a little bit on the, you know, has a hand in both or a foot in both camps. So,
right. Mm-hmm.
Yeah. So I think, you know, just making people aware that they don't have to till, I think is a good step. And then for the growers, if we can figure out how we can get greater access to seed drills for them, then they'll, I think, adopt no-till practices more readily.
I guess an alternative might be to find some finer equipment, something smaller, something practical, where if you can draw a line in the soil and drop your seeds down into the line and then gently cover them up, or cover it with some mulch.
Will it be a good idea in that case? Will it be a good idea to also kind of just make sure that maybe you can do reduced tillage, and in that case you have the disturbance in one specific spot where you always do your planting, and make sure that the other spots are not disturbed. If the soil is so compact that you may not be able to do, you can do that. So you are always disturbing just one spot, and then the other spots are left intact for the soil hub to build up. Yeah.
I think you pretty much nailed it.
Yeah. Well, Isaac, I'll just add that, you know, this is a major direction that I see your program headed. is soil health. And I think we can teach others how to do it given time. But getting people kind of cued in to understand it is the first step. And then we can expand it from there. I know that when I was out at Whipstone a couple of years ago, they had a seed drill that they had bought, you know, an old used one, but they were planning on using it. And even just finding who has perhaps one in the Verde Valley that could get out and maybe do some seeding and maybe even some contract work is something that we can learn about and share over time too. And then certainly up in Coconino County as well. So those are my 2 cents. I enjoyed the program today. I feel sorry for Mike every time he presents because there's only been a few times I've been to his presentations where he really felt good about what he had to say. And most of the time people are trying to run him out of town after he delivers his message. So Mike, thanks for keeping at it. I see you're still here. So
thanks, Jeff. Yeah, one of these days I'm going to give a happy talk.
It's always a pleasure to hear from
Okay,
you, though.
I'll share some polls, just a quick poll for us to just give some feedback. So I'm just launching it for some feedback. Can you see it now?
Yes.
We can see it. Isaac, you still have a question in the chat box from Oakley?
Oh, okay. Can you read that out? I think
I can read it to you. It says,
I tend a favorite book for no-till farming or other resources that's okay, yeah, definitely we have some materials that can be shared with you on no-till farming. I have a textbook on that, which is a PDF I can share with you.
There's another question before then from Oakley.
Oh, the one from Acrosanti, right?
No, the one before that.
Let me see. Can you read it out? Maybe I'm missing it.
I'll read it to you. It says, I tend to see a lot of soil profiles on the soil web survey in the area with very shallow bedrock, like 30 inches. Is this type of profile impossible or unadvisable to farm on?
Definitely you wouldn't prefer to have like a deep-rooted plant like pinto beans or it's just a matter of crop selection, I guess is the way I would put it. But 30 inches is not too bad. When you get down to the shallow soils, it's less than 20 inches. I can't imagine what you would want to plant in less than 20 inches. But if you got 30, that's 20 to 30. That's something you can work some things with.
I also said this right. So if the crop needs like a deep, if the crop you're growing is a deep layer crop that requires to grow very deep, you have to really consider that very well. Like James is saying, it's not advisable to just, that hard pan is going to limit your crop from growing. And then also, even when you water, that also is going to cause issues. The water cannot percolate nicely. So, are there other more questions? I saw from Acrosanti that they're indicating some rain data for us.
Isaac, the other thing that I would share about resources is that SARE, S-A-R-E, the Sustainable Agriculture Research and Extension, they have some very inexpensive books or free PDF books on cover cropping. And it goes across the whole nation, but there's some really good ideas in there, both warm season and cool. It's free. It would take me a little bit of time to find it, but you know, I go online, and if you, I think it's called Benefits of Cover Crops or Profitability and Cover Crops. And I find it when I'm looking for it if I do a Google search. And it's a great resource. It has pictures, it's in very plain language, and very usable.
Okay. I think I came across it sometime, but like you said, I cannot lay hands on it right now. I'll try to look for it and share in, with the audience later on. I think we don't have any more questions that need to be addressed, do we?
I don't think so.
Okay. So on this note, I want to thank James and then Mike for making time to support us in this program, to give us their talk. We really enjoyed it. And we hope that we'll keep bugging you once in a while to come and give us some update if we see the need for some more details from you. And other participants, we thank everyone else who has made the time to be with us. Our next meeting will be in September. So I will share the link with you when the time is approaching for us to be able to participate. Please let's try and share the information with other colleagues, other farmers as well. So we'll get most of our friends and families who are involved in farming to come on board so we can have more discussions on the topics that are required.
And Isaac, in the chat box, I posted a link to that SARE cover crops for profitability. It's a link in there, and the folks on the call will be able to link to it and then download their free copy.
Okay, yeah, I've seen it. I just click on the link and it's open. Yeah, thank you, Jeff, for sharing that with us. So you can click on the link. I'll leave it open for some time so you can click on it before you leave, so you can have it open before you leave so you don't lose it.
Isaac, I appreciate you